Okay, so you are going to explore this thing called inverse functions. And here I've given you two functions. And first I want you to find g of f of 10. Let's work from the inside out. This is not new. So for part A, we're looking for g of, well, clearly f of 10. If I was going to plug 10 in for x would be 3 times 10 plus 4, so g of 34. And g of 34, now I need to go to my g of x function. 34 minus 8 is 27. Okay, no big deal there. Let's do B. So for part B, we're going to find f of g of 10. So working from the inside out, g of 10 we can do. 10 minus 7 is 3. So really we're looking for f of 3, which is going to, if we plug 3 into our f of x function, 3 times 3 is 9, plus 4 is 13. All right, so for C, g of f of x, so in other words, we're looking for g of this whole 3x plus 4 thing. So I'm going to look at my g of x function. I have that thing minus 7, right there's my x. I'm going to plug 3x plus 4 into that thing, combine like terms, and that just gives me 3x minus 3. Same thing for D, f of g of x, so that's f of x minus 7. Well, my f function is 3 times that thing plus 4. That thing is x minus 7, so that's going to give me 3x minus 21 plus 4, which just leaves us with 3x minus 17. Okay, no big deal. We're just plugging things into functions. Let's look at our next example. Okay, different functions. So g of f of 10. So this is going to be g of, well, again, f of 10, if I plug that in, that's going to give me 34. And for g of that, I'm going to have 34 minus 4 all over 3. So that's going to give me 30 over 3, which is 10. Okay, so I'm just going to make a note of that. So that's going to give me 10. F of g of 10, which is going to be f of, well, let's see, g of 10, if we plug 10 in here, 10 minus 4 is 6, and 6 divided by 3 is 2. So really I'm looking for f of 2, which is going to give me 3 times 2 plus 4, which is 10. So this gives me 10. If I look at g of f of x, so g of f of x, again, is this thing, 3x plus 4, and that's going to be, right, for g of x, it's blank minus 4 over 3, and the thing I'm plugging in is 3x plus 4. If I combine like terms on the top, the 4's cancel out, and I'm just left with 3x over 3, which is just x. So that's x, and f of g of x is f of, let's see, g of x is x minus 4 over 3. So my f function, I'm going to take 3 times whatever I have in the parentheses, which is x minus 4 over 3. I'm going to add 4, but when I go to simplify, the 3's cancel out, and when I combine like terms, the 4's now cancel out. This just becomes x minus 4 plus 4, which is just x. So these functions are behaving very differently than the one before. So let's just go a little bit further and see what else we can do. There's something going on with these. So once again, f of x, if I remember correctly, I'm just going to write this down for myself. F of x was 3x plus 4. And our next direction, find the ordered pair. So if in fact this was our domain, in other words, these are the x values that we're plugging in, the input values. So let's see, if x was negative 3, this would become 3 times negative 3, negative 9 plus 5 plus 4 is negative 5. If we plugged in a negative 2, that would give us negative 6 plus 4, negative 2. If we plug in a 0, that would give us 4. If we plug in a 5, that would give us 15 plus 4, 19. If we plug in a 12, that's going to give us 3 times 12 is 36, plus 4 is 40. And if we plug in 15, 3 times 15 is 45, plus 4 is 49. Okay, so these are ordered pairs that are going to be on this f of x function. Now, use the output values that you found for f of x, so these ones, and use them as input values for g of x. So let's see, once again, g of x, I need to remember this, was x minus 4 over 3. Okay, so let's do this. So if we plug in negative 5 for x, that's going to give us negative 9 divided by 3, which is negative 3. If we plug in the negative 2, that's going to give us negative 6 divided by 3, which is negative 2. If we plug in a 4, that's going to give us a 0. If we plug in a 19, 19 minus 4 is 15. 15 divided by 3 is 5. You can notice a relationship here. If we plug in a 40 into g of x, this is going to give us 36 on the top divided by 3, which is 12. If we plug in 49, well, 49 minus 4 is 45 divided by 3 is 15. Okay, so here is the deal. These two functions are called inverse functions, and you've noticed a few things about them. Number one, you've noticed that this is true. When you plug one into the other, you always come up with exactly what you started with. What's easier to note is that the ordered pairs are flip-flopped. The ordered pairs are flip-flopped. That's the nature of inverse functions. So if you had some function, let's call it m of x, that's composed of the set of ordered pairs, I don't know, 5, 25, 6, 36, 2, 4, then the inverse, and this is how your textbook describes inverse function. It is not a negative exponent. The inverse of this function would be denoted by this, and it would consist of 25, 5, 36, 6, and 4, 2. Okay, here's the other thing that we're going to notice. The domain of our original function, notice it was 5 and 6 and 2. Well, those very numbers appear as the range of the inverse, which makes sense because our x and y values flip-flop. Similarly, the range of m, if you look at those numbers, the range of m, 25, 36, 4, they become the domain of the inverse. The domain of the inverse. So, things to remember. If you have inverse functions, the x and y values flip-flop. The x and y values flip-flop, and so do the domain and the range. And the other thing you need to know is notation. If m is your function, then this is how we denote the inverse, or what I prefer, some textbooks use this, but yours does not, inverse of m.